Hey guys, so I have the notes done here. Just wanted to make a video to kind of explain. So we're basically, you can see the title here. We're writing the equation of a line from a table of values, and then this question here. You may just pass it right by and not pay attention, but the reason we're able to write the equation fairly easily here with the table, write the equation of a line using a table. The reason we're able to do that fairly easily is, it's not too complicated, is because this is a yes. Are the x coordinates consecutive? Check it out, they are. -3, -2, -1, 0, 1. -1, 0, 1, 2, 3. I'm looking at the x coordinates and they are all consecutive. -2, -1, 0, 1, 2, 0, 1, 2, 3, 4. -1, 0, 1, 2, 3. So again, the fact that the x values are consecutive, that just means it doesn't go from it doesn't go 1, 6, 8, 3 or 1, 10, 2. It doesn't skip around. The numbers are consecutive integers. So the fact that they're consecutive allows me to then move to the y coordinates and see how they're changing. So anyhow, you see the steps. First thing I'm going to do is, once I recognize the x coordinates are consecutive, I'm going to identify the slope by looking at the y coordinates and verifying not only how much they're changing by, but whether it's adding or subtracting, and of course also verifying that it is the same consistent constant amount each time. So in this first one, the slope or the rate of change is a +2 because 0 + 2 is 2, 2 + 2 is 4, 4 + 2 is 6, 6 + 2 is 8. And anyhow, so the +2 is a consistent change, and that is our rate of change, aka our slope, 2. Remember, we call that m because it tells us how a line moves. And then b = 6. Well, guys, that's where the line crosses the y-axis. B is the y-intercept. It's where we begin if we're graphing, but that's pretty easy to get also, because you will find the y-intercept where x = 0. So you find where x is 0, and the y output there, the output that is your y-intercept. So on this one, x is 0, y is 6, 6 is my y-intercept. Once I have my slope and y-intercept, I can plug it into this formula, y = mx plus b. So, we are writing our equation in slope-intercept form, and so I'm going to plug in a 2 for m and a 6 for b to get y = 2x plus 6, and that's the equation of the line that is represented by these points. Same thing in this one. We can identify the rate of change. I know it's already written in here, but you can verify it's a -2. 15 minus 2 is 13, -2 is 11, -2 is 9. So we have our slope, -2, our rate of change, and our y-intercept is 13 because where x is 0, the output is 13. So that's our y-intercept, 13. Once we have those numbers, we can plug them into y = mx plus b. So y = -2x plus 13, as you see there. And basically the same thing on the rest of these three. On the next one, you can verify that the rate of change is +9, right? The rate of change, aka the slope, is a +9, so m is 9. And then 0, 15 is my y-intercept, so b = 15. And then y = mx plus b, so y = 9x plus 15. That's the equation that would represent these points. And even though these tables are set up vertically, it doesn't matter. You see your x coordinates are still consecutive, and you check what your rate of change is in your output from one output to the next. And in this one, you can see it's a +5, -18 + 5, -13 + 5, -8 + 5, and then -3 + 5. So our rate of change is +5. So our slope m is 5. And then your y-intercept is at 0, -18, so there's that. So y = 5x minus 18. And then the last one, same thing on the last one. Everything is consistent still. The rate of change here is a -5, right? 4 minus 5 is -1. -1 minus 5 is -6. -6 minus 5 is -11, and -11 minus 5 is a -16. So you have a consistent and constant rate of change. Your slope, that is, -5. And then your y-intercept is at 0, -1. So b = -1. So y = mx plus b. One last time here. Y equals, dang it, y equals -5x minus 1. So that's about it. Definitely practice in ALEKS. There's an ALEKS assignment that goes with this. Practice Unit 2, Practice 3. So that's about it, guys. Take care.